Yeah, discrete event simulation. Okay, it's a the basic building blocks of all discrete event simulation models are entities, attributes, activities, and events. Okay, here we'll be discussing today's class what is system, what is model, what is system state, what is entity, what is attribute, what is list. Okay, we'll be discussing this all the basic building blocks of all discrete event simulation models we'll be discussing in today's session. Okay, a system is modeled in terms of it states at each point in time. System is modeled in terms of its state at each point in time, and the entities that pass through the system, and the entities that represent the system resources. Okay, the entities that pass through the system and the entities that represent the system resources. Using these, the system will be modeled. Okay, next, the activities and the events that cause the system state change. Okay, using all these three things, the system will be modeled. Okay, the system is modeled in terms of its a state at each point in time, and the entities that pass through the system, and the entities that represent the system resources. Okay, next one is the activities and events that cause the system state to change. Activities and events that cause the system state to change. All these things will be used to model the system. Okay, discrete event models are appropriate for those systems for which changes in the system state occurs only at discrete points in time. Okay, this discrete event models are appropriate for the systems for those which changes in the system state occurs only at discrete points in time. Okay, the system will change its state at discrete point in time. Okay, for that these discrete event models will be appropriate. Okay, next we'll discuss the concepts in discrete event simulation. Okay, it's very very important. These are the definitions here we will be studying. In what are the concepts we are going to use, what terms we are going to use in this discrete event simulation we'll be studying here. The first one is system. What is system? System is a collection of entities. For the entities we can say the example as people, or machine is an entity, person is an entity. Okay, something is a entity. Okay, system is a collection of entities that together over time to accomplish one or more goals. Okay, it's a collection of entities. Those entities are together over a time to accomplish some task, is called a system. Okay, system is a collection of entities that together over time to accomplish one or more goals, is called system. Next one is model. Okay, model is an abstract representation of a system. It's a abstract representation of a system, usually containing structural, logical, mathematical relationships which describe a system in terms of state, entity, and their attributes, sets, process, events, activities, and delays. Okay, model, what the model represents, it's an abstract representation of a system. Representation of a system is a model, and usually a model containing a structural and logical relationships, and that relationships will describe a system in terms of state. Okay, in terms of state, entities and their attributes, sets, processes, events, activities, delays. Okay, all that will be represented in model. Okay, model is a abstract representation of a system. Next one, next concept is system state. Okay, system state means it's a collection of variables that contain all the information necessary to describe the system at any time. System state is a collection of variables that contain all the information necessary to describe the system at any time, is called system state. Okay, it's a collection of variables that contains the information necessary to describe the system at any point of time is called system state. Understood, right? Next is entity. Entity is any object or component in the system, any object or component in the system which requires explicit representation in the model is called entity. Okay, we can say like example for the entity is a server, or customer is an entity, mission is an entity. Okay, entities are, these are the example. Entity is nothing but it's an object. Okay, or it can be an component in the system, or it can be an object in the system, or it can be a component in the system. Okay, each which requires explicit representation in the model, okay, is called entity. For the entity example is system server, system customer, machine. These are all example for the entity. Next is attributes. Attributes are the properties of a given entity. Okay, attributes are nothing but these are properties of a given entity is called attributes. Okay, example attributes is the priority of a customer, the routing of a job through a job shop is an attribute. Attribute describes the property of a given entity. Okay, next one is list. Okay, list is collection of associated entities ordered in some logical fashion. Okay, list is collection of associated entities ordered in some logical fashion. It can be ascending order or it can be descending order. We call it as collection of associated entities represented in terms of uh, in the ordered form is called a list. Okay, and this collection is permanently or temporarily we associate the entities and we represent it as a logical fashion. Okay, the list is collection of associated entities ordered in some logical fashion. It can be the ascending order or descending order, or like all customers currently waiting line, and it's according to the first come first serve order, ordered by first come first serve, or by ordered by the priority. Okay, we can order the list of associated entities will be ordered in the form of list here. Okay, list is a collection of associated entities ordered in some logical fashion. That can be the first come first serve or priority based ordering. Okay, or ascending order or descending order. Okay, that is a list. Okay, next term here is event. Event is an instantaneous occurrence. Okay, it's an instantaneous occurrence that changes the state of a system. Okay, that is called event. It's some occurrence that changes the state of a system. It can be the event can be the arrival of a new customer is an example for event. Okay, it's an instantaneous occurrence that changes the state of a system. Okay, some system may be in the ready state, because of some event the system will move from the ready state to running state. Okay, so the system needs some resources. That time because of that waiting resource, the system will change its state from running state to waiting state. Okay, it is a instantaneous occurrence that changes the state of a system is called event. Next is event notice. Event notice is a record of events to occur at the current or some future time. Okay, along with any associated data necessary to execute the event. Okay, event notice is nothing but it's a record of events to occur at that current time, and the list of events that will record of events that will occur in the future time, and those will be recorded along with any associated data necessary to execute that event. Okay, uh, excuse me. At a minimum, the record includes the event type and event time. Okay, and next term is event list. Okay, event list is a list of event notices for future events. Okay, list of event notices for the future event and ordered by time of occurrence. Okay, event list is list of events noticed for the future events ordered by time of occurrence. Okay, it is here the events will be ordered in terms of time, occurrence time. Okay, first occurred event will be represented in the first list in the list first place. Next occurred event will be represented in the next to that event. Okay, that is a list of events notices for the future events ordered by time of occurrence. Okay, also known as future event list. Event list is also called as FEL. FEL means future event list. Remember this, we will be using this term in the problem. Future event list. Future event list is nothing but list of events notices for the future events, and those events are ordered by time of occurrences. Okay, is called future event list. Next one is activity. Activity is a duration of time of a specified length. Duration of time of a specified length is called activity, which is which is known when it begins. Okay, this is called activity. A duration of time of specified length, which is known when it begins, is called activity. Okay, here the duration of time of specified length is, it can be like service time or arrival time, which is known when it begins, although it may be defined in terms of statistical duration also. Okay, activity is nothing but duration of time of specified length, which is known when it begins, is called activity. Next is, next term is delay. Delay is a duration of time of unspecified indefinite length. Okay, delay is a duration of time of unspecified indefinite length. Okay, unspecified indefinite length of duration of time is called delay. Okay, which is not known until it ends. Delay we don't know until which will get ends. Okay, something like indefinite length of time duration, which is not known until that is ends, is called delay. Okay, example, a customer's delay in last in first out waiting line, which when it begins depends on the future arrivals. Okay, next one, next term is clock. Clock is a variable representing simulated time. Okay, here we use the clock. Clock is a variable representing a simulated time. We'll discuss these concepts in discrete event simulation by using a Abel-Baker problem. Okay, in Abel-Baker problem, how do we are going to represent these concepts, we'll see now. Okay, this is example of Abel-Baker problem. Here, consider the Abel-Baker car hop system, and a discrete event model has following components, like a system state. System state LQ of T, which will represent the number of cars waiting to be served at time T. Okay, at time T, number of cars are waiting for the service will be represented by LQ of T. Okay, and another system state is LA of T. Okay, LA of T will be 0 or 1 because it is single server system. Okay, LA of 1 come, LA will be 0 or 1. Okay, it to be 1 to be indicate able being idle or busy at that time. Okay, only the able, it will, LA will specifies that able's service time, whether the able is servicing or not. Okay, if able is not idle means it will be represented as LA of 0, and if the able is busy servicing some customer, that time LA of T will be represented as 1. Next, LB of T. LB of t also it will be 0 of or 1 to indicate the baker being idle or busy. Okay, it is baker or able. Uh, if the able is busy, it represents LA of t will be represented 1. If the baker is busy, LB of t will be represented 1. Okay, this LA of t and LB of t will be either 0 or 1. 0 means waiting state. Okay, server, able server is at waiting state. And if LB of t is 0 means the baker server is waiting state. Okay, LA of t is 1 means able is servicing the customer. Okay, LV of t is 1 means the baker is servicing the customer. Okay, that way these are the different system states in able baker problem. Here the entities are neither the customer nor the servers need to be explicitly represented except in terms of the state variables unless certain customer advan averages are decide. Okay, this is the entities here. Next events here is arrival event. Okay, service completion by the able and service completion by the baker. Okay, here we have more than one server, two servers are there, one is able and one is baker. Okay, so here there are possible events are three, that is arrival event. Arrival event is customers arrive to the system. Okay, and service completed by the able is one event, service completed by the baker is another event. Next activities here is inter-arrival time, service time by the able, service time by the baker. Okay, these we have discussed while solving the able baker problem. Okay, inter-arrival time, service time by the able and service time by the baker. And here delays. Delays is a customer's wait in the queue until able or bakery becomes free is delay. And the definition of the model components provides a static description of the model here, and a description of the dynamic relationships and interactions between the components is also needed here. Okay, and a discrete event simulation, the modeling over time of a system, all of whose state changes occur at discrete points in the time. Those points when event occurs will be modeled by using discrete event simulation. And discrete event simulation proceeds by producing a sequence of system snapshots. This discrete event simulation proceeds by producing a sequence of system snapshots. Okay, this is about discrete event simulation. We will discuss the event scheduling and time advanced algorithm. Okay, event scheduling and time advanced algorithm, it's the mechanism for advancing simulation time and guaranteeing that all the events occur in correct chronicle order is based on the future event list. Okay, this is a mechanism for advancing simulation time and guaranteeing that all the event occur in the correct chronicle order is based on the future event list. Okay, and here the what is future event list? Future event list will be list of events will be represented in some order. Okay, future event list, this is to contain all the event notices for events that have been scheduled to occur at the future time. Okay, the which will consist of event notices. Event notices are nothing but event records, which will be representing all the events which are going to occur in the future time. Okay, future simulation clock time is future event list, and to be ordered by the event time. And these events, whatever events are in the event notices, those events need to be ordered by event time. Okay, that is occurrence. According to the occurrence of event, the event list need to be ordered. Okay, like t is less than t1, t1 is less than or equal to t2, and t2 is less than or equal to t3, and then tn. Okay, like this we should do order according to the time. If some event occur at t, so that should be placed first in the future event list, next t1, next t2, next t3 event, next t4 event, like that the event should be placed in the ordered format. Next, scheduling a future event. Scheduling a future event means that at the instant an activity begins, its duration is computed or drawn as a sample from the statistical description. Okay, and the end activity event, together with its event time, is placed on the future event list. This is scheduling a future event. Okay, the sequence of actions which a simulator must perform to advance the clock system snapshot is called event scheduling and time advanced algorithm. What is event scheduling and time advanced algorithm? It's a sequence of actions which a simulator must perform to advance the clock system. Okay, sequence of actions which should be done to uh, perform a advance the clock system. Okay, that is called event scheduling or time advanced algorithm. The sequence of actions which a simulator must perform to advance the clock system is called event scheduling or time advanced algorithm. Okay, we'll see the steps in that event scheduling and time advanced algorithm, which is very, very important. Event scheduling and time advanced algorithm. First step, remove the event notice for the imminent event. Okay, from the future event list. First, we need to remove the event notice for the imminent event, the event which is occurred at that point of time. That event need to be removed from the future event list. Okay, step 2, advance the clock to imminent event. Okay, advance the clock to imminent event. Whatever event is occurred, that events, the particular event time, the clock, simulation clock should be advanced, that is increased. Okay, that is advance the clock from R to T1. Okay, previously the simulation clock time was R. That clock time we need to advance it to T1, because T1 there is an event. Okay, next, step 3, execute imminent event, update the system state. Run the event and update the system state and change entity attributes and set membership as needed. Okay, that is the step 3. Execute the imminent event, update the system state, change entity attributes and set membership as needed. Next, step 4, generate future events if necessary. Okay, and place their event notice on FEL, future event list, ranked by the event time. Okay, according to the event time, we need to represent in future event list. Okay, generate future events if any future events are there. Generate future events and place their event notice in future event list, ranked by event time. According to their event occurrence time, we need to order those future events in the future event list. Okay, that's what the step 4 says. Next, step 5, update the cumulative statistics and counters. Update the cumulative statistics and counters. This is the event scheduling and time advanced algorithm. Okay, next topic here is manual simulation using event scheduling. Here, a simulation table is used to record the successive system snapshots as time advances in the event scheduling simulation. Like example, if we say single channel queuing system, okay, that means only one server will be there to serve the customer. Okay, the model has the following components, like system states will be LQ of T or LS of T. Okay, LQ of T is the number of customers in the waiting line will be represented as LQ of T. How many people are waiting for the system to get serviced, that way those customers will be in the waiting line. Okay, number of customers are in the waiting lines will be represented as LQ of T. Next is LS of T. ls of t is the number of is the number of, is the number being served. Okay, that is the customer is whether idle state or sorry, whether the server is idle state or server is servicing, which is represented as ls of t. Okay, this is the number being served, whether it can be 0 or 1. Okay, at that time, at that simulation clock time t. Okay, these are the system state. Entities are server and the customers are not explicitly modeled. Okay, except in terms of state variables. Okay, here the events are arrival event, departure event, and stopping event. Okay, when the simulation we wanted to stop, that is nothing but stopping event. And arrival event is when the event occurs, when the customer comes to the uh, server. Okay, at what time, that is arrival event. When the customer completes its service is departure event. Okay, arrival event, departure event, stopping event. And event notices are nothing but a comma t, d comma t, e comma t. A comma t representing an arrival event to occur at future time t. Okay, a comma t represents an arrival event to occur at future time t. D comma T represents a customer's departure event. Okay, it represents the customer departure at future time t. And E comma T represents a simulation stop event at future time t. What time we need to stop our simulation, that will be represented as E comma T. Okay, next here the activities are interval time and service time are the activities, and delay is customer time spent in the waiting line is delay. How much time the customer spent in the waiting line will be specified as delay here. Okay, this is event notice are written like this. Okay, execution of the arrival time. The arrival event occurs at clock t. That time is ls of t is equal to 1. That means the server is busy. Okay, if s increase lq of t by 1, that means the customer who has arrived, he will be sent to the queue. Okay, if ls of t is equal to 0 means set ls of t to ls of t is equal to 1, and then serve the customer who had arrived here. Okay, generate service time a star, schedule the new departure event at time t and t plus a star. Okay, next is generate the interval time a star, schedule the next arrival event at time t plus a star. Okay, collect the statistics, return the control to the time advanced routine to continue the simulation. Okay, this is the process. Okay, event notice are written like this. Execution of arrival event will be like this. When the event occurs, we need to check whether ls of t is equal to 1. If it is equal to 1, put that arrived customer to the queue. If it is ls of t is equal to 0, then assign that the customer to the server and make initialize the ls of t is equal to 1, and customer will be assigned with the server. Server will service the customer. Then generate inter-arrival time and schedule next arrival event, and then collect the statistics, return the control to the time advanced routine to continue the simulation. Next is execution departure event. Execution of departure event is departure event occurs at clock time t. That time we need to check whether ls of t is greater than or equal to 0. That means the server is servicing. Okay, if it is equal to 0 means server is waiting. If it is greater than or equal to 0 means, if it is yes, then reduce the lq of t by 1. Okay, lq of t q, if server is not serviced, reduce the one person from the queue, assign the server with the person. Okay, if ls of t is greater than or equal to 0 is not, then set ls of t equal to 0 and collect the statistics, return the control to the time advanced to continue the simulation. Okay, with this we have done with the theoretical concepts related to discrete event simulation.